Welcome to the channel NextGen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Cloud Security Engineer certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
Your organization operates in a highly regulated environment and has a stringent set of compliance requirements for protecting customer data. You must encrypt data while in use to meet regulations. What should you do? The options are: Option A, enable the use of customer-supplied encryption keys, CSEK, keys in the Google Compute Engine VMs to give your organization maximum control over their VM disk encryption. Option B, establish a trusted execution environment with a confidential VM. Option C, use a shielded VM to ensure a secure boot with integrity monitoring for the application environment. Option D, use customer-managed encryption keys, CMEK, and Cloud KSM to enable your organization to control their keys for data encryption in Cloud SQL.
To arrive at the correct answer, we focus on the keywords, encrypt data while in use.
The correct answer is Option B, establish a trusted execution environment with a confidential VM.
Why is this correct? B. Confidential VMs use hardware-based memory encryption to provide a trusted execution environment, ensuring that your data remains encrypted while in use by the processor in memory. Why are the others incorrect? A. Customer-supplied encryption keys, CSEK, for VM disk encryption protect data at rest, not data while it is in use. C. Shielded VMs provide verifiable integrity and secure boot features to protect against rootkits and bootkits, but they do not encrypt data while in use. D. Customer-managed encryption keys, CMEK, with Cloud KMS for Cloud SQL protect data at rest, not data while it is in use.
Your organization is building a real-time recommendation engine using ML models that process live user activity data stored in BigQuery and cloud storage. Each new model developed is saved to Artifact Registry. This new system deploys models to Google Kubernetes Engine and uses pub/sub for message queues. Recent industry news have been reporting attacks exploiting ML model supply chains. You need to enhance the security in this serverless architecture, specifically against risks to the development and deployment pipeline. What should you do? The options are: Option A, enable container image vulnerability scanning during development and pre-deployment. Enforce binary authorization on images deployed from Artifact Registry to your continuous integration and continuous deployment, CVCD, pipeline. Option B, thoroughly sanitize all training data prior to model development to reduce risk of poisoning attacks. Use IAM for authorization, and apply role-based restrictions to code repositories and cloud services. Option C, limit external libraries and dependencies that are used for the ML models as much as possible. Continuously rotate encryption keys that are used to access the user data from BigQuery and cloud storage. Option D, develop strict firewall rules to limit external traffic to Cloud Run instances. Integrate intrusion detection systems, IDS, for real-time anomaly detection on pub/sub message flows.
To arrive at the correct answer, we focus on the keywords, saved to Artifact Registry, deploys models to Google Kubernetes Engine, attacks exploiting ML model supply chains, risks to the development and deployment pipeline.
The correct answer is Option A, enable container image vulnerability scanning during development and pre-deployment. Enforce binary authorization on images deployed from Artifact Registry to your continuous integration and continuous deployment, CVCD, pipeline.
Why is this correct? A. Vulnerability scanning in Artifact Registry and binary authorization ensure that only trusted, scanned, and approved container images are deployed to GKE, directly mitigating supply chain attacks and securing the development and deployment pipeline. Why are the others incorrect? B. While data sanitization helps prevent poisoning, it doesn't secure the CI/CD deployment pipeline against supply chain attacks on container images. C. Key rotation and limiting dependencies are good general practices, but they do not enforce security gates in the deployment pipeline like binary authorization. D. The scenario uses GKE, not Cloud Run. Additionally, IDS on pub/sub doesn't protect the container image supply chain or deployment pipeline.
You want to set up a secure, internal network within Google Cloud for database servers. The servers must not have any direct communication with the public internet. What should you do? The options are: Option A, assign a private IP address to each database server. Use a NAT gateway to provide internet connectivity to the database servers. Option B, assign a static public IP address to each database server. Use firewall rules to restrict external access. Option C, create a VPC with a private subnet. Assign a private IP address to each database server. Option D, assign both a private IP address and a public IP address to each database server.
To arrive at the correct answer, we focus on the keywords: secure, internal network, database servers, not have any direct communication with the public internet.
The correct answer is option C, create a VPC with a private subnet. Assign a private IP address to each database server.
Why is this correct? C. Creating a VPC with a private subnet and assigning only private IP addresses ensures the database servers reside on an internal network and cannot communicate directly with the public internet. Why are the others incorrect? A. Using a NAT gateway provides outbound internet connectivity, violating the strict requirement that the servers must not have any direct communication with the public internet. B. Assigning a static public IP address enables direct internet communication, violating the core requirement, despite any firewall rules applied to restrict access. D. Assigning a public IP address allows direct communication with the public internet, which directly contradicts the requirement for no public internet access.
You work for a large organization that recently implemented a 100 GB cloud interconnect connection between your Google Cloud and your on-premises edge router. While routinely checking the connectivity, you notice that the connection is operational, but there is an error message that indicates MASEC is operationally down. You need to resolve this error. What should you do? The options are: Option A, ensure that the cloud interconnect connection supports MASEC. Option B, ensure that the on-premises router is not down. Option C, ensure that the active pre-shared key created for MASEC is not expired on both the on-premises and Google Edge routers. Option D, ensure that the active pre-shared key matches on both the on-premises and Google Edge routers.
To arrive at the correct answer, we focus on the keywords: 100 GB cloud interconnect connection is operational, MASEC is operationally down.
The correct answer is option D, ensure that the active pre-shared key matches on both the on-premises and Google Edge routers.
Why is this correct? D. When a cloud interconnect link is operational but MASEC is down, the primary cause is a mismatch between the pre-shared keys, CKN and CAK, configured on the Google Edge router and the on-premises router. Why are the others incorrect? A. All 10G and 100G dedicated interconnect connections inherently support MASEC, making lack of support an invalid cause for the failure. B. The question explicitly states that the connection is operational, meaning the on-premises router is functioning and not down. C. Pre-shared keys used for MASEC on Google Cloud Interconnect do not have an expiration property. Failures stem from mismatched keys rather than expired ones.
For compliance reasons, an organization needs to ensure that in-scope PCI Kubernetes pods reside on in-scope nodes only. These nodes can only contain the in-scope pods. How should the organization achieve this objective? The options are: Option A, add a node selector field to the pod configuration to only use the nodes labeled in-scope, true. Option B, create a node pool with the label in-scope, true, and a pod security policy that only allows the pods to run on nodes with that label. Option C. Place a taint on the nodes with the label in scope, true and effect no schedule and a toleration to match in the pod configuration. Option D. Run all in-scope pods in the namespace in-scope PCI.
To arrive at the correct answer, we focus on the keywords. In-scope PCI Kubernetes pods reside on in-scope nodes only. These nodes can only contain the in-scope pods.
The correct answer is option C. Place a taint on the nodes with the label in scope, true and effect no schedule and a toleration to match in the pod configuration.
Why is this correct? C. Taints and tolerations ensure that nodes repel pods that do not tolerate the taint. This guarantees that only the specifically configured in-scope pods can be scheduled on the in-scope nodes, satisfying the exclusive isolation requirement. Why are the others incorrect? A. A node selector directs pods to specific nodes, but it does not prevent other, non-in-scope pods from being scheduled on those same nodes. B. Pod security policies manage pod-level security settings and privileges, but they cannot restrict pods to specific nodes or repel unwanted pods. D. Namespaces provide logical isolation within the cluster, but do not dictate physical node scheduling or prevent pods from sharing underlying nodes.
You are developing an application that runs on a compute engine VM. The application needs to access data stored in cloud storage buckets in other Google Cloud projects. The required access to the buckets is variable. You need to provide access to these resources while following Google recommended practices. What should you do? The options are: Option A. Limit the VM's access to the cloud storage buckets by setting the relevant access scope of the VM. Option B. Create IAM bindings for the VM's service account and the required buckets that allow appropriate access to the data stored in the buckets. Option C. Grant the VM's service account access to the required buckets by using domain-wide delegation. Option D. Create a group and assign IAM bindings to the group for each bucket that the application needs to access. Assign the VM's service account to the group.
To arrive at the correct answer, we focus on the keywords: compute engine VM, access data stored in cloud storage buckets, other Google Cloud projects, required access to the buckets is variable, Google recommended practices.
The correct answer is option B. Create IAM bindings for the VM service account and the required buckets that allow appropriate access to the data stored in the buckets.
Why is this correct? B. Creating IAM bindings for the VM service account directly on the required buckets provides fine-grained, variable access across projects, following Google recommended practices. Why are the others incorrect? A. Access scopes are a legacy authorization method that applies to the entire VM. IAM bindings offer the required fine-grained control. C. Domain-wide delegation is meant for impersonating Google Workspace users to access their data, not for granting standard service account access to cloud storage. D. Creating a Google group to manage access for a single service account introduces unnecessary complexity. Direct IAM bindings are simpler and preferred.
Your organization strives to be a market leader in software innovation. You provided a large number of Google Cloud environments so developers can test the integration of Gemini in Vertex AI into their existing applications or create new projects. Your organization has 200 developers and a 5-person security team. You must prevent and detect proper security policies across the Google Cloud environments. What should you do? Choose 2. The options are: Option A. Apply organization policy constraints. Detect and monitor drifts by using security health analytics. Option B. Publish internal policies and clear guidelines to securely develop applications. Option C. Use cloud logging to create log filters to detect misconfigurations. Trigger Cloud Run functions to remediate misconfigurations. Option D. Apply a predefined AI-recommended security posture template for Gemini in Vertex AI in Security Command Center Enterprise or Premium tiers. Option E. Implement the least privileged access identity and access management roles to prevent misconfigurations.
To arrive at the correct answer, we focus on the keywords: large number of Google Cloud environments, Gemini and Vertex AI, 200 developers and a 5-person security team, prevent and detect proper security policies.
The correct answers are option A, apply organization policy constraints. Detect and monitor drifts by using security health analytics. And option D, apply a predefined AI recommended security posture template for Gemini and Vertex AI in Security Command Center Enterprise or Premium tiers.
Why is this correct? A. Organization policy constraints actively prevent misconfigurations at scale. Security Health Analytics centrally detects and monitors deviations, providing necessary automation for a small security team. D. Security Command Center's predefined AI recommended security posture templates specifically target Gemini and Vertex AI, enabling a small team to efficiently prevent and detect issues without manual rule creation. Why are the others incorrect? B. Relying on published internal guidelines provides no automated enforcement or detection, making it highly ineffective and unscalable for 200 developers. C. Building custom remediation with cloud logging and cloud run functions introduces immense operational overhead for a 5-person team and does not prevent initial misconfigurations. Why are the others incorrect? E. Least privilege IAM is essential but only covers access control. It does not provide the comprehensive, environment-wide detection and automated prevention required.
You are responsible for managing identities in your company's Google Cloud organization. Employees are frequently using your organization's corporate domain name to create unmanaged Google accounts. You want to implement a practical and efficient solution to prevent employees from completing this action in the future. What should you do? The options are: option A, create a Google Cloud identity for all users in your organization. Ensure that new users are added automatically. Option B, implement an automated process that scans all identities in your organization and disables any unmanaged accounts. Option C, register a new domain for your Google Cloud resources. Move all existing identities and resources to this domain. Option D, switch your corporate email system to another domain to avoid using the same domain for Google Cloud identities and corporate emails.
To arrive at the correct answer, we focus on the keywords: managing identities, corporate domain name to create unmanaged Google accounts, prevent employees from completing this action.
The correct answer is option A, create a Google Cloud identity for all users in your organization. Ensure that new users are added automatically.
Why is this correct? A. Proactively creating cloud identity accounts ensures users already have managed accounts. This practically and efficiently prevents them from creating unmanaged consumer accounts using the corporate domain name. Why are the others incorrect? B. Scanning and disabling accounts is a reactive approach rather than a preventive one, meaning unmanaged accounts can still be created initially. C. Registering a new domain is highly impractical, unnecessarily disruptive to the organization, and does not directly address the issue with the existing domain. D. Switching the corporate email system to another domain is an extreme, complex measure that disrupts business operations without efficiently solving the identity problem.
Your organization leverages folders to represent different teams within your Google Cloud environment. To support infrastructure as code, IAC, practices, each team receives a dedicated service account upon onboarding. You want to ensure that teams have comprehensive permissions to manage resources within their assigned folders while adhering to the principle of least privilege. You must design the permissions for these team-based service accounts in the most effective way possible. What should you do? The options are: option A, grant each service account the folder administrator role on its respective folder. Option B, grant each service account the project creator role at the organization level and use folder-level IAM conditions to restrict project creation to specific folders. Option C, assign each service account the project editor role at the organization level and instruct teams to use IAM bindings at the folder level for fine-grained permissions. Option D, assign each service account the folder IAM administrator role on its respective folder to allow teams to create and manage additional custom roles if needed.
To arrive at the correct answer, we focus on the keywords, folders to represent different teams, dedicated service account, comprehensive permissions to manage resources within their assigned folders, adhering to the principle of least privilege.
The correct answer is option A. Grant each service account the folder administrator role on its respective folder.
Why is this correct? A. The folder admin role grants full control over folders, allowing teams to create and manage projects and resources within their assigned folder. This satisfies the requirement for comprehensive resource management permissions while adhering to the principle of least privilege. Why are the others incorrect? B. Granting roles at the organization level violates least privilege. The project creator role only allows creating projects, failing to provide the comprehensive permissions needed to manage other resources within the folders. C. Assigning project editor at the organization level severely violates the principle of least privilege by inappropriately granting broad access across the entire organization, rather than restricting access to specific folders. Why are the others incorrect? D. The folder IAM admin role only allows managing IAM policies on the folder. It does not provide the comprehensive permissions required to manage the actual resources and projects within the assigned folder.
Your organization has a workload that is regulated by European laws. You must restrict the creation of resources outside of the EU for this specific workload. You must find an effective way to implement this security control without disrupting the other global applications. What should you do? The options are: Option A, create a cloud function triggered at asset creation that detects and deletes resources outside of the EU. Option B, create all your workload's assets in a regional subnet in the EU in one project or folder. Option C, segment your workload in the EU in one project or folder by using VPC Service Controls. Option D, implement an organization policy that only allows the EU as the location for your workload's project or folder.
To arrive at the correct answer, we focus on the keywords, restrict the creation of resources outside of the EU for this specific workload, without disrupting the other global applications.
The correct answer is option D. Implement an organization policy that only allows the EU as the location for your workload's project or folder.
Why is this correct? D. Organization policy constraints, such as resource locations, can be applied to specific folders or projects to proactively prevent the creation of resources in unauthorized regions without impacting global applications. Why are the others incorrect? A. This is a reactive approach. Resources would temporarily exist outside the EU before being deleted, violating the strict compliance requirement and creating unnecessary overhead. B. Deploying assets in an EU subnet only affects compute engine networking. It does not prevent the creation of other services like cloud storage outside the EU. C. VPC service controls are designed to mitigate data exfiltration risks, not to restrict the geographical location where resources are provisioned.
Your organization manages a critical web application that serves international customers on Google Cloud. An increase in malicious traffic targeting this application has strained resources and caused periods of downtime. You need to design security measures to increase the application's resilience against web attacks, enhance perimeter protection, and provide access control. What should you do? The options are: Option A, employ network load balancing for traffic distribution. Update identity-aware proxy (IAP) policies to allow only administrative access. Implement custom firewall rules on all external IP addresses. Option B, set up firewall rules on compute engine instances within the application's environment. Rely on load balancers for threat detection. Increase instance resources to cope with attack volume. Option C, configure firewall rules to block traffic from known malicious IP ranges. Set up Google Cloud Armor and implement Identity-Aware Proxy (IAP) for granular access control. Option D, add firewall rules that restrict all internal IP ranges. Establish Cloud DNS security policies. Disable external IP addresses to reduce the attack surface. Create user groups for access control.
To arrive at the correct answer, we focus on the keywords: web application, malicious traffic, resilience against web attacks, perimeter protection, access control.
The correct answer is option C. Configure firewall rules to block traffic from known malicious IP ranges. Set up Google Cloud Armor and implement Identity-Aware Proxy (IAP) for granular access control.
Why is this correct? C. Cloud Armor provides WAF and DDoS protection to build resilience against web attacks. Firewall rules enhance perimeter protection by blocking malicious IPs. IAP implements strong identity-based access control without exposing back-end infrastructure. Why are the others incorrect? A. Network load balancing operates at layer 4 and lacks application layer WAF capabilities. Additionally, restricting IAP to administrative access prevents international customers from using the application. B. Load balancers alone do not provide advanced threat detection or WAF capabilities. Increasing instance resources is merely a reactive measure that fails to mitigate attacks, enhance perimeter protection, or provide access control. Why are the others incorrect? D. Disabling external IP addresses makes the critical web application inaccessible to its international customers. Cloud DNS security policies do not mitigate application layer web attacks or provide appropriate perimeter protection.
Your organization deploys a large number of containerized applications on Google Kubernetes Engine, GKE. Node updates are currently applied manually. Audit findings show that a critical patch has not been installed due to a missed notification. You need to design a more reliable, cloud-first, and scalable process for node updates. What should you do? The options are: Option A, configure node auto upgrades for node pools in the maintenance windows. Option B, develop a custom script to continuously check for patch availability, download patches, and apply the patches across all components of the cluster. Option C, migrate the cluster infrastructure to a self-managed Kubernetes environment for greater control over the patching process. Option D, schedule a daily reboot for all nodes to automatically upgrade.
To arrive at the correct answer, we focus on the keywords: Google Kubernetes Engine, GKE, node updates are currently applied manually, design a more reliable, cloud-first, and scalable process for node updates.
The correct answer is option A, configure node auto upgrades for node pools in the maintenance windows.
Why is this correct? A. Node auto upgrades in GKE provide a reliable, cloud-first, and scalable way to ensure nodes are kept up to date with security patches. Using maintenance windows allows you to control when these upgrades happen, minimizing disruption to your applications. Why are the others incorrect? B. Developing custom scripts increases operational overhead, is prone to errors, and is not a cloud-first approach compared to using native GKE features like auto upgrades. C. Migrating to a self-managed Kubernetes environment drastically increases management overhead and complexity, negating the benefits of a managed service like GKE. D. Simply rebooting nodes does not automatically apply Kubernetes node upgrades. An upgrade process involves replacing or updating the underlying node image.
Your organization is migrating its primary web application from on-premises to Google Kubernetes Engine, GKE. You must advise the development team on how to grant their applications access to Google Cloud services from within GKE according to security recommended practices. What should you advise the development team to do? The options are: Option A, configure the GKE nodes to use the default Compute Engine service account. Option B, enable workload identity for GKE. Assign a Kubernetes service account to the application and configure that Kubernetes service account to act as an Identity and Access Management (IAM) service account. grant the required roles to the IAM service account. Option C, create a user-managed service account with only the roles required for the specific workload. Assign this service account to the GKE nodes. Option D, create an application-specific IAM service account and generate a user-managed service account key for it. Inject the key to the workload by storing it as a Kubernetes secret within the same namespace as the application.
To arrive at the correct answer, we focus on the keywords, grant their applications access to Google Cloud services from within GKE, according to security recommended practices.
The correct answer is option B, enable workload identity for GKE. Assign a Kubernetes service account to the application and configure that Kubernetes service account to act as an identity and access management (IAM) service account. Grant the required roles to the IAM service account.
Why is this correct? B. Workload identity is the recommended, most secure way to grant GKE workloads access to Google Cloud services. It links a Kubernetes service account to an IAM service account, avoiding manual key management and preventing excessive node-level permissions. Why are the others incorrect? A. Using the default compute engine service account violates the principle of least privilege, as all pods on the node would inherit its broad permissions. C. Assigning a custom service account to GKE nodes still grants the same IAM permissions to all workloads running on those nodes, violating least privilege. D. Creating and storing service account keys as Kubernetes secrets is a security anti-pattern because keys are long-lived credentials that risk being leaked and require manual rotation.
Your organization has Google Cloud applications that require access to external web services. You must monitor, control, and log access to these services. What should you do? The options are: Option A, set up a secure web proxy that allows access to the specific external web services. Configure applications to use the proxy for the web service requests. Option B, set up a Cloud NAT instance to allow egress traffic from your VPC. Option C, configure VPC firewall rules to allow the services to access the IP addresses of required external web services. Option D, configure Google Cloud Armor to monitor and protect your applications by checking incoming traffic patterns for attack patterns.
To arrive at the correct answer, we focus on the keywords, access to external web services, monitor, control, and log access.
The correct answer is option A, set up a secure web proxy that allows access to the specific external web services. Configure applications to use the proxy for the web service requests.
Why is this correct? A. Secure web proxy allows you to secure, monitor, and control egress web traffic to external services based on policies and provides comprehensive access logging. Why are the others incorrect? B. Cloud NAT provides internet access for private instances but lacks fine-grained application-level control, URL filtering, and specific web service monitoring. C. VPC firewall rules operate at the network and transport layers based on IPs and ports, lacking the fine-grained application layer control and detailed logging required. D. Google Cloud Armor is a web application firewall designed to protect incoming, ingress, traffic to your applications, not outgoing, egress, traffic to external services.
Your organization's application is being integrated with a partner application that requires read access to customer data to process customer orders. The customer data is stored in one of your cloud storage buckets. You have evaluated different options and determined that this activity requires the use of service account keys. You must advise the partner on how to minimize the risk of a compromised service account key causing a loss of data. What should you advise the partner to do? The options are: Option A, scan the cloud storage bucket with sensitive data protection when new data is added, and automatically mask all customer data. Option B, define a VPC Service Controls perimeter and restrict the cloud storage API. Add an ingress rule to the perimeter to allow access to the cloud storage API for the service account from outside of the perimeter. Option C, ensure that all data for the application that is accessed through the relevant service accounts is encrypted at rest by using Customer-Managed Encryption Keys, CMEK. Option D. Implement a secret management service. Configure the service to frequently rotate the service account key. Configure proper access control to the key, and restrict who can create service account keys.
To arrive at the correct answer, we focus on the keywords, service account keys, minimize the risk of a compromised service account key causing a loss of data.
The correct answer is option D, implement a secret management service. Configure the service to frequently rotate the service account key. Configure proper access control to the key, and restrict who can create service account keys.
Why is this correct? D. Using a secret management service to frequently rotate keys and restrict access limits the lifespan and exposure of keys, directly minimizing the impact of a potential compromise. Why are the others incorrect? A. Masking data alters the information the partner needs to process orders and does not address the root security risk of managing the service account key. B. Adding an ingress rule to allow access from outside the perimeter means an attacker with the compromised key could still access the data, failing to mitigate the risk. C. CMEK protects data at rest but does not prevent an attacker using a compromised service account with read permissions from decrypting and accessing the data.